is week 6, chapter 6, page 161 from the Abu Dhabi text. All right, part 1. We had to go back and find the data set in chapter 5 for question 1, and here it is right here. Boom. And it wants us to find a 95 and a 99% confidence interval. So let's just type them out here. 95% CI, and this is going to be a 99% CI. CI stands for confidence interval. So I'm just going to pick a cell, any cell. I'm going to go to the function bar. And there it is right there, confidence norm. So that's going to give us the margin of error. We're going to click OK. And it wants the alpha. Remember, 1 minus the confidence interval is the alpha, right? The level of confidence, which is the same thing as confidence interval. So 95%, 1 minus 90% is 5%, which is 0.05, right? Or 5%. Standard deviation, we don't know yet. And we're going to have to calculate that. And then the sample size is 18. So we're going to have to figure out the samples. We're going to have to figure out the standard deviation real quick. And let me cancel that out. So standard deviation, I'll just put this over here. Standard deviation equals, we go back here, and then we go to standard deviation. And I always use the standard deviation of the sample size. I don't want to go into a lot of detail about why, but we're going to do it that way. We're going to go statistical St. Dev S. Where are you? St. Dev S. There you go. Boom. And of this data. And that is it. Boom. I'm going to make it big. Big, 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 big. Okay. So now I could go back here. And then I'm going to go to the formula bar, and I want confidence norm. Norm. There it is right there. Again, this is going to give us the margin of error, the plus or minus factor. Okay, so same thing. 95% being subtracted from 100% is 5%, so I'll just stick in 5%. And the standard deviation is that number. And the sample size is 18. Enter. Boom. So there's our plus or minus factor. Now we got to find the mean, right? We'll find the mean over here. And I'm just going to go up to the function bar and find average. There's the average. This is taking way too long. I'm about to switch over here. Switch it over to SPSS. It'll take about 1/10 of the time here. Click. But there's our mean. So for the 95, let me get that bigger. Come on, get bigger. You boom, boom, boom. All right, so for the 95% guy, our low value, I might as well type in the high value. High value is going to be, I'm going to go to the function bar, hit equals, and I'm going to say, so for the low number, I'm going to take the mean of 35, and I'm going to minus the margin of error, right? And that's going to be my answer. Boom. And for this, for the high value, I'm going to go up to the function bar, hit equals, and I'm going to say, take the mean, and then this time add that margin of error. And that's our answer, but I'm going to clean it up so we can see it here. I don't need that many zeros. Where are my zeros? 0, 0, there they are. Boom, boom, boom. And let's put it in the middle, and let's make it bold, and let's make it bigger. Boom, boom, boom. Okay, there's a 95% confidence interval with this data. And now let's go down here and make a 99%. And we're basically going to do the same thing, right? We already know the mean and the standard deviation, so we just go equals. Oh, I'm sorry. This is a mistake. Please hold. I'm going to go to this cell. This is going to give us our margin of error, right? This is our margin of error. Right, that plus or minus the Z star, which tells us which level of confidence, which confidence level, 90%, 95%, 99%, that kind of stuff. And then that is multiplied by the standard deviation divided by the square root of the sample size. That's what this is. Okay, so again, I don't need so many freaking decimals. You're crazy. You're crazy. And let's do this right. We get format pattern. Boom. So again, so we're going to go here. Now you'll notice the formula is the same. What I'm going to do is I'm going to cheat. I'm going to copy the formula. Go down here and hit V. Wait a minute, something weird happened. All right, I'm going to copy the formula. C. I'm going to click out of it. I'll hit enter. There you go. Now I'm going to go up here and then paste it. But now you'll notice that this is a 99%, so I'm going to change that 5%. So 1 minus 99% is 1%. That is our new alpha. Everything else should be the same. Boom. That's our plus or minus factor. So this guy is going to be equals. Wait, you can't even see that, can you? Okay, let's move this over so you can see it. So our low score, or beginning of the interval, is going to be equals. It's going to be the mean. That's way over here. Minus the margin of error. Enter. This one is going to be equals the mean plus the margin of error. That's my answers. Those are your answers right there. Now, real quick, we're going to do these in SPSS from now on. This just kind of takes too long. But again, here's the answers right there. And let me put them on that paper. Hold on. And so they go right there. But again, let's switch this over to SPSS and show you how fast this sucker is. Now, the numbers might be a little bit different, but at this point in the game, they're going to be close regardless. So I highlighted the data, I copied the data, going back to the SPSS, and this is the other worksheet that we're going to need from Chapter 5. So I'm just going to add it right into the same worksheet so we don't get overburdened here. We'll just put it right here, boom, paste, and we're going to name them exercise hours, right? Hours. Exercise. Did I spell exercise? No, I think there's an S in there. And we make sure that it is a scale variable. That looks good. Good. So now watch how fast it is to make a confidence interval. We're going to go to Analyze. We're going to go to Descriptives. We're going to go to Explore. And I'm going to stick in... that's down at the bottom. Hours of exercise. Boom. Boom. And now dig, man. So this is going to give us the 95% confidence interval right there. See that? Boom. It's going to give us the 95%. So let's just go ahead and take a peeky. And where are you? Oh, this is the wrong one. Okay, hold on a second. So watch how fast this goes. We're going to go to Analyze, Descriptive Statistics, Explore, boom. And hours of exercise. Now, dig, man. It gives you the confidence interval. You can change that to whatever you want. You can't go below 50, okay? So, but 95%, that's the first question. And we're going to click them right there. And there they are, right? 32.63 and 37.37. What did we get here? We got 32.8 and 37.2. Well, let's just compare the two here. And confidence. 32.6 And so Excel got 32.8 and 37.37, 37.2, close enough for me. Now we're going to do the 99% confidence interval, and it will be a little bit different. But again, I suggest you use SPSS. It's just a whole lot easier. So we can go to Analyze again, Descriptives, get in there, you Explore. And this time we're going to ask for the 99% confidence interval. And there it is, there it is, there it is, there it is. So 31.75 and 38.26. 38.75 and where'd you go? Get in there, you. So 38 point. I'm sorry, I already lost it here. 30. So 31.75. 31.75 is a little bit different than the Excel, and then the 38.25 a little bit different for there. So either one of those is, I'll give you full credit on those, because the difference is SPSS did it exactly where Excel, we use the standard deviation of a sample, so that changed that number off a little bit. So you're going to get a little bit of different answers, but that's all, either one of these is the best way to go. And again, from now on, use SPSS. It's just a ton faster. And what does this mean? This means this. That the true population mean is somewhere between 32.80 and 37.20 hours of exercise. Got it? Clean it up. My God, for spell check. And then the other one means this. Right? You're just 99% sure. You're a little bit more sure. Now, you're a little bit more sure is because the number range, the interval itself got bigger, right? So if the numbers to choose from get bigger, you should be a little bit more confident, and that's exactly what happened. So this is 32.11. And this is 37.89. Got it? Those are the answers. Here, let's get these all highlighted. And, oh, shoot. Please hold. Let's get these highlighted. Where'd he go? All right, so there's number 1 and number 2. So again, use SPSS. Put the data in SPSS. Do it the way the video did, and it's just a lot faster. Okay, so let's switch down to part 2. All right, part 2. We're going to use the self-esteem data from chapter 2, which I have right here. I have this in the SPSS. That was the one. I believe I put it in the thing for a link for you. But it's got the self-esteem questions, the one that we reverse coded, etc., etc. Here's our self-esteem variable. So let's go back to the question. So the null and the one-tailed research hypothesis predicting the relationship between age and self-esteem. Okay, let me pause this real quick. All right, the null is always easiest. It says there's nothing going on here, but I changed the word relationship to correlation. Relationship means many things to many people in statistics, but since this is a stats class, we're going to say the correlation between age and self-esteem is 0. In other words, there is no correlation between age and esteem. And self-esteem. And then the alternative to that, they want a one-tailed test. So we came out and we said the correlation between age and self-esteem is greater than, beep, 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 greater than or less than beep, 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 beep. Either one of those is fine, 0. So this makes it a one-tailed test because we're saying that one side is larger or smaller than the other. It doesn't matter if it's 0, whatever you're comparing the two between. So again, if we say it's larger or smaller than, that gives you the less than or greater than symbols, that automatically means it's a one-tailed test. Okay. So what are the IVs and DVs in question 1 and their levels of measurement? So the IV is age, because that's what we believe is predicting self-esteem, and the DV is self-esteem because that's what we think changes over age. Boom. And they're both continuous variables. Right? In other words, they're just regular counting numbers, right? Continuous, ratio, scale, whatever you want to call it. That's the answers to this one. Man, we're rolling now. All right, let's keep going. So back to number 2, right? Age is the explanatory variable, and self-esteem is the response variable, or response variable. So in other words, age causes self-esteem, right? Cause and effect. So, okay, never mind. Run a histogram for the DVs. That means self-esteem. Let's get back over here. We're going to run a histogram. That's going to check for normality. And we're going to go to analyze. Again, there's a ton of different ways to do this. Let's just go to analyze, descriptives. We'll go to explore. And out with exercise, in with self-esteem. And we want the histogram. Might as well check for normality. Doesn't hurt anything. So there's your histogram, and jeez, it's a mess, right? And he also wants the skewness. There's the skewness. So the skew statistic is negative 0.513, and the standard error is that. Let's see what he was looking for here. Evaluate the skewness coefficients. It's terribly skewed. There's no question about it there. So hold on, let me cut and paste that stuff in there for you. So here's the histogram. Bam, it is obviously skewed. And what else did he want? He wanted the coefficients, I believe. Where'd he go? Oh, shoot, hold on. Evaluate the skewness coefficients. There's the skewness coefficients right there. Boom. And we don't need to evaluate them. That's obviously skewed. And then we would look at the Kolmogorov-Smirnov test or the Shapiro-Wilk or both. Let's put these where you can see them. Now this one says it's barely skewed, right? Remember, less than 0.05, it violated the assumption. So this is saying it barely violated the assumption. But this one says wholeheartedly it there's no question about it, right? This is much less than 0.05. And looking at it, you can already tell that it's violated the assumption of normality. There's no question. Okay, based on number 2, what statistical test appears to be most pretty examine the hypothesis in question 1? Why? What is the alternative test? So question 1 was the correlation. So since the data is not normal, which is a misunderstanding, God, I hate to confuse you guys, but normality is not an assumption of a correlation. It's the normality of the standardized residuals. I said that a million times. I'm getting tired of saying that. But because this guy thinks that the data is not normal, you would use the other test. The other test is called the Spearman's rho. Rho. Now the letter rho in Greek looks like a little p. I'm not going to write it. But the Spearman's rho, or just the Spearman's correlation, or whatever the heck this guy wants to call it. But it's not true. Again, normality, right? The hump thing is not an assumption of correlations. And he, like too many other people, got that mistaken with the t-test. Right, t-test, the DV should be normal, but not correlations. Okay, I'm not talking about it anymore. And state a null and two-tailed research hypothesis predicting the relationship between ethnicity and education. Question 5 is easy. State the null and a two-tailed research hypothesis predicting the relationship between ethnicity and education. All right, let me put you on hold for 1 second. Please hold. All right, the null is easy. It says there's no relationship between ethnicity and education. Right? No relationship. So I'm assuming that they're talking about a correlation because relationship means correlation, but it can be interpreted as other things in statistics just to make it harder on you guys. But that's the null. There's nothing going on between ethnicity and education. The alternative is there is something going on, right? There is a relationship between ethnicity and education. This is a two-tailed because we're not saying that one is bigger than the other, right? Say that again. This is a two-tailed because we're not saying that the correlation is greater than 0 or less than 0, right? You're not using those words, larger, smaller, greater than, less than. That makes it a two-tailed test. All right, moving on up. What are the independent and dependent variables in question 4 and their levels of measurement? All right, here's question 4. Oh, shit, look at that. Based on questions 2 and 3. God dang this book. What is this to be appeared? Okay, so it's a Spearman's row. This is in question 1. Jeez. What? Okay, so question 1 back here was, all right, between self-esteem and 0. So this is the one way back from question 1. I think that's what he's asking. Let's go back down here to question 6. All right, independent is the causer. So this is your IV, age. And this is your DV, self-esteem. The levels of measurement. Didn't we do this already? They're both continuous, right? Age and self-esteem. Yeah, they're both continuous. Not sure I got this one right, but, you know, it ain't me, it's the book. All right, what are the independent and dependent variables in question 4? Question 4, based on your answers for question 2 and 3. Fudge. What statistical test appears to be the most appropriate example in question 1? Oh, my God. So again, question 1, okay, that's okay. I'm giving up on this one. So I'm pretty sure this is right, but who cares? This is ridiculous. This is just going into the twilight zone of education. So, all right, what statistical test appears to be the most appropriate to blah, 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 number 5? Fudge. So you look at the variables. Okay, relationship between ethnicity, which is categorical, and education, which is ordinal. You have 2 different ways to go here. You could either run a chi-squared test, which looks at the association, or what we used to call relationship, but now we call it association, if I could spell it, association, between 2 categorical variables. And, okay, before you rip me apart, ethnicity is definitely a categorical variable or a nominal variable. Now, the level of education could be a categorical variable because it's only got three levels, right? Or it could be an ordinal variable. So if you're going to treat them both like categorical variables, you would use the chi-squared test. If you were going to treat them as if your level of education, if your education was used as an ordinal variable, you would use the non-parametric version of the between group ANOVA, which I know you guys don't like already. And it's called, I believe, the Kruskal-Wallis test. Kruskal-Wallis Wallace tests. And I'm going to print them out for you right now, so hold on. So this is a chi-square test. You'll notice the significance is nowhere near under 0.05, therefore there's no significant. But in the old days, we just use the word association these days. In other words, was there an association between the levels of education and the different groups of ethnicity? So this is the chi-square test. It says no significance. This is the Kruskal-Wallis test. Same thing. It says no significance. Look at the asymptotic significance. That's all you need to know. But these are the two tests you would run. And this all comes from that paragraph of decision tree use in the book. You know, most people take weeks, you know, chapters and chapters on which test to use because it is very complicated, but this guy does it in a paragraph. So, okay. And computer 99% confidence interval for self-esteem. Didn't we do that already? Son of a gun. Oh, no, we did it for exercise. Okay. Self-esteem. We're going to cheat. We're going to do it the fast way. Analyze. Descriptives. Get in there, you. Boom. Explore. Oh, there's self-esteem right there. So, boom. We're going to just change this to, oh, look at that, 99%. We did do it. Didn't we do it? There it is right there. Boom. Self-esteem. So there's the lows part. And let me just put those in there. Copy, copy, copy. And we'll pasty, pasty, pasty. And we only want the confidence interval, so we'll delete the rest of this crap. And delete cells and get rid of the rows. So there it is right there. Bam. There's your high and your low. I hope that helped. But that's it, you guys. Okay. I hope it helps. And again, I apologize. This book is just something else. It really is. So, and okay, I'm not going to say anything else. Okay, I'll see you in about an hour. Okay. MGZ out.